Dear students, Assalamu alaikum wa rahmatullahi wa barakatuh. Today we will start our syllabus for the third prep. And we will start with the first lesson in Unit 1, which is called Motion in One Direction. Firstly, we need to know what is meant by motion. As we see here, the car moves from place to another place. So, motion, it is the changing of the object position as the time passes. When the object changes its position, it means it moves. As we can see here, the train changes its position as the time passes, so it moves. We have two factors are used to describe the motion. When I have two persons or two means of transportation are moving, we need to describe their motion and compare between them. We will say that one of them is faster than the other, or one of them is slower than the other. To describe the motion as fast or slow, we need to know two things. Firstly, the distance covered by this object. Secondly, the time taken to complete the motion or the trip. So, to compare between two moving objects, we use speed. We said that the car is faster than the bicycle. Why? Because the car covers longer distance or larger distance in short time. Or, in other words, we will say that the bicycle covers small distance in a long time when we compare it to the car. So the speed is the distance covered per unit time. This was the definition of speed. The law of speed is distance divided by time. When we use symbols, we will replace speed with V, distance with D, and time with T. The distance is measured by meter or kilometer, while the time is measured by second or hour. So the unit of speed will be meter per second or kilometer per hour. When the distance with meter, the time will be with second. When the distance with kilometer, the time will be with hour. In any problem, if we have the speed with kilometer per hour and we need to change it into meter per second, what will we do? We have many options. We can set that the speed in kilometer per hour, the value of speed in kilometer per hour divided by 3.6 will equal the speed in meter per second. Why divided by 3.6? Because to convert from kilometer to meter, we need to, the 1 kilometer contains 1000 meters, and the hour contains 60 minutes, and the minute contains 60 seconds. So, from kilometer to meter, we multiply the value times 1000, and from hour to second, multiply the value of hours by 60 times 60. This factor, if we simplify it, it will be divided by 3.6. Or another factor, time 5/18. Let's see this problem. If we have a train that travels from Cairo to Alex, a distance of 250 kilometers, in 2 hours. So the distance covered is 250 and the time is 2 hours. Find the speed in kilometer per hour and meter per second. Firstly, we will answer this problem by getting the speed in kilometer per hour. We must write three things. Firstly, the rule. Secondly, the steps of your answer, and finally, the final answer and the unit. Speed equal to 150 divided by 2 equals 125 kilometer per hour. So the speed in meter per second will be 125 divided by 3.6. So it will equal 34.72 meter per second. Now, let's talk about the types of speed. We have two types of speed. The first type is uniform speed or regular speed. In uniform speed, the object covers equal distances at equal periods or intervals of time, which means that the body moves by equal distance. If we talk about a car, the car covers 100 meters every 10 seconds. So we can say that the car moves with uniform speed. And the second type is non-uniform speed or irregular speed. In this case, we can say that the body or the object covers equal distances at unequal periods of time, or the object covers unequal distances at equal periods of time. What is meant by those two definitions? By the way, each of them is correct. The first means that if we have a car that covers the first 100 meters in 10 seconds and the second 100 meters in 13 seconds and the third 100 meters in 9 seconds, so it covers equal distances, but the time interval is not equal. The other definition means that the car at the first 10 seconds it covers 100 meters. At the second 10 seconds it covers, for example, 80 meters. And in the third 10 seconds it covers 70 meters. So at equal periods of time the distances are unequal. And the device which is used in cars and planes to measure the speed is called speedometer. It's very difficult, or it's not possible to determine or to calculate the regular speed of an object that moves practically, because there are some conditions that will affect the speed of any moving object, as the traffic or the road condition. So the moving objects are moves with non-uniform speed. That will allow us to talk about average speed, V dash. What it is meant by average speed? Average speed, it is the total distance that a moving object covers divided by the total time takes to cover this distance. The speed is the distance covered per unit time, but the average speed is the total distance, because we talk about an object that moves with irregular speed. So it covers unequal distances in equal period of time or equal distances in unequal period of time. So the average speed will be the total distance that covered by the object divided by the total time taken to cover this distance. And the rule will be average speed or V dash, we add this line or dash to differentiate between the speed and the average speed. It means total distance divided by total time. Let's see this problem. Find the average speed for a person that covers a distance from point A to point B. The distance from A to B is 100 meters. It covers this distance in 10 seconds, and the distance from point B to point C is 44 meters. It covers the 44 meters in 2 seconds. So we have an object that moves with irregular speed. So the distance from A to B is different from the distance from B to C. And here the time differ from that time. Let's see how to answer it. Firstly, we write the rule. V dash equal total distance divided by total time. The total distance equal the sum of all distances that the object covers. 100 plus 44 divided by the total time, which is 10 seconds plus 2 seconds. It will be 144 divided by 12. So the final answer will be 12 meters per second. So the average speed for that person is 12 meters per second. It means that if that person move the total distance, which is 144 meter with a regular speed, its speed will be 12 meters per second. And now with the last thing related to the speed, which is relative speed. Relative speed, it is the speed of a moving object relative to an observer. What is meant by this definition or relative speed? Relative, it means related to another person that observe or see the moving object. The relative speed is the speed of the object, but it's not the actual speed, but it is the speed related or according to the observer that will notice or observe the motion. We have 3 cases. The relative speed depends on the position of the observer. Firstly, if the observer at rest, it means that the observer speed equal 0. He doesn't move. So in this case, the relative speed will equal the real or the actual speed of the object. So the relative speed equal to the real speed of the object. Only in this case, the 2 speeds are equal. In the second case, the observer at a moving object, but the direction of movement here is opposite to the direction of the object that we need to calculate its speed. So here, if the observer is moving in the opposite direction of the moving object, the relative speed will equal the sum of the 2 speeds, the observer speed and the real or the actual speed of the moving object. So in this case, the relative speed is the sum of 2 speeds. So the relative speed is bigger than or more than the real speed or the actual speed of the object. The third case, the observer is moving in the same direction of the moving object but with a different speed. And you will see soon why the speed must be different. In this case, the relative speed equal the difference between the 2 speeds. the real speed of the car and minus the observer speed. So the relative speed is less than the real speed. In this point, we must say something. The speed can't be negative, never. The speed can't be negative value. So the difference between the two speeds must be a positive value, not negative. What happens if the observer in a moving object that move in the same direction of the other car and with the same speed? Let's take a small example. If the actual speed of the object is 100 km and the observer speed is 100 km and both of them are in the same direction, so the relative speed will be the difference between two speeds, 100 minus 100. In this case, 100 minus 100 equals 0. So the observer will see the other car as stopped car, or it doesn't move. Why? Because in this case the relative speed equals 0. Here in this case, if they are at different speeds, the relative speed will be less than the real speed, because the relative speed is the difference between two speeds. As we said, when the two bodies move in the same direction and same speed, the body seems as fixed or doesn't move or stop according to the observer due to the relative speed equal 0. Let's see this video.
Relative motion of objects. Have you ever wondered as to why a train coming from the opposite direction appears to be faster than a train moving in the same direction? To answer the above question, we have to understand relative motion of objects. Consider a passenger sitting at the window seat of a train as an observer. Case 1. When the train in which the observer is sitting is moving with a velocity v1 of 30 km per hour, and another train is coming towards the first train with a velocity v2 of 60 km per hour. In this case, from the frame of reference of the observer, it appears that train coming towards him is moving faster at a speed of 30 plus 60 is equals to 90 km per hour. Whereas from the frame of reference of a person standing on the station, both the trains are moving with velocities of 30 km per hour and 60 km per hour. Hence, in the case of train moving in opposite direction, from the perspective of the observer sitting in one of the train, it appears that approaching train coming from the other direction is moving faster with net velocity being the sum of v1 and v2. Case 2. When both the trains are moving in the same direction with same speed of 60 km per hour, that is, v1 is equals to v2 is equals to 60 km per hour. In this case, from the frame of reference of observer, it appears that the other train is stationary. But from the frame of reference of a person on the station, both the trains are moving at a speed of 60 km per hour.
And now, let's talk about something related to our topic today, which is how to calculate the time that the light takes to reach to the earth from the sun. To calculate the time, we need to know two information, which are the speed of the light and the distance between earth and sun. And both the two information are fixed and known. From the relation V equal D divided by T, we can calculate the time. The distance between Earth and Sun is 149 million kilometers, and the speed of the light is 300,000 kilometers per second. So we have the two information, and we need only to calculate the time. The speed of light equal distance divided by time. So the time equal distance divided by speed. And the distance is known, and also the speed of light is a known information. So the time will be 497 seconds, approximately 8 minutes and 17 seconds. That means if the time of sunset is 5 o'clock, it is determined that the light traveled from the sun at 4 o'clock and 51 minutes and 33 seconds. By the end of this part, we end our lesson today. We hope you enjoy our lesson. Thank you, and hope to see you again in other lessons. Thank you and goodbye.